Welcome to Semester 2. So our first unit that we'll be studying in Semester 2 will cover chemical reactions. Chemical reactions are predictable, and our goals for this unit, we want to be able to predict how combinations of substances can result in physical and/or chemical changes, interpret and apply the law of conservation of mass, balance chemical equations using the law of conservation of mass, and classify chemical reactions as synthesis, decomposition, single displacement, double displacement, or combustion. Today we're going to focus on predicting how combinations of substances can result in physical and/or chemical changes.
Chemical and physical changes. Say hello to Mark and Molly. Each are enjoying a glass of water. Deciding to save some for later, Molly puts her glass in the refrigerator, and Mark decides to put his in the freezer. A short time later, they go to get their drinks. Molly enjoys her cold liquid water, but something has happened to Mark's water. His has physically changed. Matter can undergo a chemical change or a physical change. A closer look at ice will show us that frozen water is H2O molecules made of hydrogen and oxygen atoms. When the ice cube melts, the molecules stay H2O. They just change from a solid to a liquid. Even when water evaporates, the molecules might be moving a little faster, but they're still water molecules. Another example of a physical change would be bending iron metal. Iron can be made into I-beams or pressed into shapes. Whether the iron is in a beam or in a shape, it still is Fe atoms, just in a different shape. A chemical change occurs when an entire new material is created or the atoms become rearranged. Iron rusting is a chemical change because the iron turns into a new material. The process of rusting can be seen in a chemical formula. Iron plus water plus oxygen yields iron 3 oxide, or rust. In this chemical equation, we start with iron, but end up with something brand new. Another chemical change happens when you eat sugar. Sugar enters your body as C6H12O6. When you breathe in oxygen gas, a chemical change begins. The sugar is broken down and turned into carbon dioxide and water. The sugar molecule has chemically changed. Another chemical change happens when you drive your car. Gasoline enters your car as octane. Octane is C8H18. In your engine, oxygen is introduced, and the octane changes into carbon dioxide and water. This is a chemical change because octane is no longer a molecule. Something new has been created. You can tell the difference between chemical and physical changes because chemical changes can't easily be undone, but lucky for Mark, a physical change can be undone, and his glass of water is almost back to a liquid. Chemical and physical changes.
So just to recap from the video, when a substance undergoes a physical change, its identity remains the same. So you're not changing physically what it is, you're just kind of changing the state that it's in. Some examples would include melting butter, molding clay, melting and cooling a metal to reshape it, crushing a can, cutting paper. You're not actually changing chemically what the substance is, you're just changing something about it. I like to think of physical changes as kind of being like Superman and Batman. So Superman and Batman, they basically go into their telephone booth and they change their clothes and they morph into their superhero form. So they're not really physically changing what they look like. And at the chemical level, they're still the same person. So you have Clark Kent. He's still Clark Kent. He just has a Superman outfit on. Same thing, Bruce Wayne, he just puts his little Batman costume on and becomes Batman. This is not a perfect comparison because objects that undergo physical change don't only change their surface. They change other things as well, like shape, phase, or even color. Chemical changes, this is when a substance undergoes a chemical change and a new substance is created. So when you burn candles, if you mix vinegar and baking soda, fireworks, that's a chemical reaction, decaying fruit, smells. Anytime you have a smell, that's a chemical change. You're actually smelling a chemical reaction. And I like to think of chemical changes as kind of like the Hulk. He's kind of an example of a chemical change. So he starts out as a human man, but his entire body becomes bigger, greener, and his personality becomes violent. So he chemically becomes a different thing. He doesn't just wear a costume. This isn't perfect though, because the Hulk changes back into a human being. Most chemical changes, I'm not going to say they're all irreversible, because they're not, but when you go through a chemical reaction, it's not like a physical change where you can just take your ice cube and melt it back into water. And the next thing that I really wanted to show you guys, reactants form products. So I wanted to kind of go over the anatomy of a chemical reaction. Your reactants, those are what you start out with, and here in this case it's A plus B. You might think of it like hydrogen and water. Your products are what you end up with. That would be like, in this case it's C and D. If you mix hydrogen and oxygen, you could get H2O, which is water. So reactants are on the left side of the arrow, products are on the right side. This arrow, usually you read it as either yields or produces.